Hey there, hi there, ho there. Welcome to the Unit 1 lecture on geology and Earth's formation. We got to start somewhere, so we'll talk a little bit about what geology is in general and how the Earth formed. Seems like a good place to start. Let me turn on the light here. Okay. So let's go ahead and just jump into this, shall we? As you're watching these lectures throughout the semester, please watch and listen. Don't just listen. Don't just put these in the background while you're cleaning or cooking and listening, because there's things I'm going to show you on here that are relevant to what I'm saying. So make sure you're paying attention in that aspect. Each unit's lecture is broken up into a series of videos. Sometimes the videos are a couple minutes long, up to maybe about 15 minutes long. And we'll break up the lecture like that in a series of small videos. Should you ever have any questions of the material contained in any lecture this semester, please write it down, jot it down somewhere, remember it, shoot me an email, shoot me a message through Canvas, or ask me during class time. So let's go ahead and talk about geology and Earth's formation, shall we? So, geology as a science. Well, what is geology? Anyone? What is geology? Yeah, that sounds about right. Kind of like a Blue's Clues thing. Anyway, so what is geology? Technically, it's the scientific study of Earth through the past 4.56 billion years. That's how old the Earth is, 4.56 billion years. So this class is specific to a branch of geology called physical geology, and that's the understanding Earth processes and materials. So knowing about rocks and how things interact, how things occur, how volcanoes occur, earthquakes occur, etc., and what makes up the Earth. That's physical geology. That's usually the starting point for any knowledge in geology, and that's what this class is. So geology is actually pretty diverse. Geology isn't just looking at rocks. Geologists are needed in a lot of different places, from studying volcanoes, from studying ice cores and the ocean, from studying construction and earth materials, all the way into outer space. In fact, one of the fastest growing areas of geology is planetary geology. So, not only knowing the geology of Earth, but what other stuff is made out of. So, why do we study geology in general? Well, it's to understand and attempt to fix society's most important problems. And you can say that probably with any science. The science is there to understand and to help, or to fix things, or to make better. Specific to geology, some of the important problems that we face deal with energy, water, mineral resources. Where's the energy from our future going to be? Do we have enough water to sustain our society? Which I'll give you a hint. If you're anywhere in Arizona watching this, this is not the best place to be in the next 10, 15, 20 years as far as water is concerned. Mineral resources. Everything is made up of stuff. Everything is made of minerals. If it's not grown, it's mined out of the ground. It's a mineral resource. Everything is kind of made up of mineral resources. So as the population of Earth gets larger, where is that material going to come from? The environment, not only with talking about things like climate change, but sustainable environment, where we build, where we live. We need to understand where it is we're looking to move to or build or live on. We need to understand that geology. And we also need to understand natural hazards like landslides, volcanoes, earthquakes, and floods. The more we understand about those, the more safe we can be when these things occur. We can't really stop these things. Landslides, volcanoes, earthquakes, floods, they're going to happen. They've happened for billions of years and will continue to do so. How do we live with that? So, what are some additional reasons besides just understanding and attempting to fix problems? What are some additional reasons to study geology? Well, Earth is our home planet. We've got to know a little bit about our home. We depend on this Earth for everything. Like I mentioned before, if it's not grown, it's mined. So, if we're talking about crops are grown, everything else is mined. You got to get it from material from somewhere. We got to pull it out of the Earth. The Earth is only as big as it is. It's a big place, but it is finite, meaning there is an end to it. Meaning if we continue to mine out material, at some point that material is going to be all gone. So with limited resources, we need to be knowledgeable and thoughtful about managing those resources. The physical and chemical processes that dictate the Earth and how it works affects everyone, believe it or not. Just because we don't live in a place necessarily with volcanoes or earthquakes, perhaps, doesn't mean that those things can't interrupt the economics or society that would eventually affect where we are at. And we must appreciate our role in geologic change, with climate change, human-driven climate change. Yes, it is us. Yes, there's a lot of people on this planet. Some say maybe too many people on this planet. But we have to appreciate our role in how we affect this planet, not only up in the sky, the atmosphere, climate change, but also on the ground as well. We are affecting and changing the Earth geologically speaking. This is a plaque that was posted a couple of years back outside of a glacier in Iceland, I believe. And this was, it's kind of a sad plaque, and it's kind of a warning for the future. It says, a letter to the future. Ok, was the name of this glacier, is the first Icelandic glacier to lose its status as a glacier. In the next 200 years, all our glaciers are expected to follow the same path. Iceland will be ice-free. This monument is to acknowledge that we know what is happening and what needs to be done. Only you know if we did it. So this is written to someone who might read this in 50 years. And there's no glaciers around. Obviously, we did not address the problem, in this case, climate change. We do, as minuscule as we are and how big we think the Earth is, we have a big impact, fortunately and or mostly unfortunately. So that's geology. All right. Now, in geology, we talk about a lot of things. And I want to just get something out of the way, and that's the word theory. What is a theory? We typically use that word incorrectly. The word theory, as you know, people think it is, so why did the bookshelf fall down? Oh, it must have been, I don't know, a ghost. Well, that's just your theory. That's just your guess. You know, we use that term theory incorrectly. That's actually not what it means scientifically. So in common everyday language, oh, that's just their theory. And you know, we talk about the Big Bang theory. Oh, that's just their guess. No, that's not what theory means in science. Oh, the theory of evolution, that's just their guess at things. No, that's not their guess. That's not what theory means in science. Be careful with that word. Theory, what it means actually in science, is the highest level of knowing in science. A theory, as common everyday language, is very low-level guess. Oh, tacos are the best food. That's just your theory. That's just your opinion, your guess. Well, no. In science, that word means the exact opposite. So don't sound dumb. All right. Be careful with that word theory. So in science, theory is the highest level of knowing. A theory is testable. It's repeatable. It's never been proven false, which is different than it being true, and it's widely accepted. So, the Big Bang Theory, how the universe got started. We can test for it. The tests are repeatable. It gives it the same results. It's never been proven false, folks. Never been proven false. Widely accepted. Theory of evolution, testable. We can look at the fossil records. When we repeat those tests, we get to the same conclusion. The theory of evolution has never been proven false. And it's widely accepted. So, it's just kind of a side note, but just be very careful with that word theory, because we will approach that word theory very soon, talking about something, the plate tectonic theory. The Earth is made up of large plates. The crust of the Earth is broken up into large plates. They interact with one another. When they interact, geology occurs, but it is known as the theory of plate tectonics. But the theory is not just their guess. Again, very high level of knowing, testable, repeatable, never been proven false. Okay? So we're going to pause there. As with, you'll see with the rest of the lectures this semester, each unit lecture, if you look at the PowerPoint, is broken up into sections, and about one video per section. Sometimes if the sections of a PowerPoint are a little bit longer, I might have to break it up into a couple videos. But for now, we're going to pause, and when we come back, we'll pick it up with section 2, just a brief history of geology. See you back here in just a second.